Okay, let's get started on 15. It's still solving. Remember I told you I was going to break it up. In this video, we're going to do C and D. And so let's take a look at C for just a minute. Notice here we have multiple logs, so we can't use the one-to-one property. One-to-one says it has to be one log equal to another log. And so since we have multiple logs, we're going to have to utilize our properties, our log properties that says we're allowed to condense so that we can make it where it's a log equal log. So let's do a quick recap. Remember, in the land of condense, a minus was code for a denominator. And so this is going to essentially be log base 6. Now it's going to be x plus 2 over x equals log base 6 of x plus 5. So this one works out where now we have a log base 6 equal to a log base 6, and now we can utilize that one-to-one property, which is very, very helpful. And so now that we have that, we can just set our insides equal to each other. So I have x plus 2 over x equals x plus 5. Now we need to clear this denominator, so I'm going to multiply both sides by x, or you can cross multiply depending again on how you're instructed. So then these cancel out. That leaves me with x plus 2 equals my x getting distributed across x plus 5. And so now I distribute x plus 2 equals x squared plus 5x, and lo and behold, I have a quadratic here. So I'm going to go ahead and work on setting it equal to 0. And so I get x squared plus 4x minus 2 equals 0. And so yeah, x minus 4, looking good, equals 0. Now, of course, I would attempt to factor this, and I'm telling you in advance, I've tried, it can't be factored, and so then that forces me to do my quadratic formula. And so x equals the negative b, which is negative 4, plus or minus the square root of my b getting squared, which is 16, minus 4 times a times c. My c is a negative 2, so that's really plus 8 over 2 times 1, which is 2. I'm doing, of course, the quadratic formula much, much faster in this problem than I would typically if I'm teaching that for the first time. And so now you get x equals negative 4 plus or minus the square root of 24 over 2. Now, normally I would say, okay, pause here, simplify that off to the side, but since it says you're allowed to round your answer, we just now have to think about it as x equals negative 4 plus the square root of 24 over 2. And you might be thinking, but what happened to the minus? Negative 4 minus anything divided by a positive is going to give me a negative. And remember, you can't have a negative inside a log. So that's going to get rejected. So all we really have to do is calculate the positive version. I can go ahead and show you both just so you can see. So this would be, let me show you what I mean. Oh, my battery's low. So here we're just going to put this in our calculator. I'm going to go ahead and put parenthesis, negative 4 plus second square root of 24. Go out of there, close the parenthesis, divided by a positive 2, and I get x equals 0.4495. But suppose I wanted to get the other one, the negative, that would be second, enter, bring it back up, change that to a minus 24, and you get x equals negative 4.4495. The problem then becomes when you go to check your work. Remember, with logs, we must check. When you go to put this one in, you get a negative 4 plus 2, and that would give me a negative, and you can't have a negative inside a log. So even with the soft check and not a formal check, we discovered the negative needs to be rejected. So the only answer we could possibly have for this one is x equals 0.4495. Okay, let's take a look at B. Again, we have multiple logs here. We can't just set these equal to each other. We have to condense. And again, that's going to be code for a denominator. So this problem feels extremely similar from the first one, but I'll go ahead and do it. Log base 8 of x minus 1 equals log base 8 of, now in parentheses, x minus 2 over x plus 2, because this is a condensed problem. Now I do in fact have log equals log, so I can set these equal to each other now. X minus 1, x minus 2 over x plus 2. Again, clear that denominator by multiplying by x plus 2. x plus 2. This works out beautifully over here, x minus 2. The only backlash is this side you'd have to multiply it out. So I get x squared minus x plus 2x minus 2. That would x squared plus x minus 2 equals x minus 2. Look, lo and behold, it's quadratic again. So we do have to be in the mindset of setting it equal to 0. Subtract x, add 2, add 2. I get x squared equals 0, or x equals 0. Again, you must check your work here. And since x equals 0, again, it doesn't have to be formal. It could be a solved. 0 minus 1 would give me negative 1, and I can't have a negative. So as soon as I have any inside become a negative or a 0, I have to reject the answer. So this one gets rejected. And for this particular answer, I actually have no solution. There's nothing that exists that will ever make this true.